All right, let's take a look at another rational function where the degree of the numerator is 1 higher than its denominator. Here we have a trinomial, a quadratic trinomial, x squared minus 9x plus 20 divided by x minus 4. Okay, so we want to sketch this based on domain range, asymptotes, intercepts, and behavior. Now, first thing before you actually even attempt to sketch this thinking, okay, there's going to be an oblique asymptote here, what you need to do is first let's factor the numerator. Let's see if it's actually factorable. And this, in fact, here this is factorable, right? So the x squared minus 9x plus 20 can be factored out as x squared minus 4x minus 5x plus 20, right? And it's because we want two numbers to add up to -9, then multiply to 20. This is a decomposition, factoring by decomposition. So you can also consider this product and sum rule. And you get x minus 4 minus 5x minus 4, and you get x minus 5 times x minus 4. Okay, so this is basically the factored form of this. And you can actually notice that there is a common factor, right? There's x minus 5 times x minus 4 over x minus 4. So you can actually notice that f of 4 here is going to be a restriction because we get 0 over 0. This is an indeterminate state. This is also indicative of a hole that's being present, right? So this is something that you have to watch out for. So just by looking at the domain, x belongs to a set of all real numbers, but x cannot equal 4 because you'd be indeterminate, right? And in that sense, if we cancel this out and we simplified it, this is the function that we're going to be working with. Okay, so f of x is equal to x minus 5. Okay, now because we said that x cannot equal 4, f of 4 should not equal 4 minus 5, which is -1. It cannot equal -1, right? So 4 and -1 is the whole, is the point discontinuity. It's the point that doesn't exist. It's the break in the function. Okay, so this is a point discontinuity, and as a result, y belongs to all real numbers, but y cannot equal -1. So this is really important to understand because this is a linear equation, right? Because now you can see that the simplified expression is a linear equation, right? So that one y value will not exist. Having said this, we can understand that for part B, so this was part A, for part B, there are no asymptotes. There is a point discontinuity. There is a hole that exists for -1. So now it becomes really straightforward, right? Because we have a linear function. So just by looking at your function x minus 5, f of x is equal to x minus 5, you can notice that the y-intercept, because this is slope-intercept form, y is equal to mx plus b, the y-intercept is 0 and -5. The x-intercept, on the other hand, we just let y equal 0, and we get x minus 5 is equal to 0, x is equal to 5. So the x-intercept is 5 and 0. Now let's sketch out this graph really quickly. Okay, so I'm just going to create a grid. Okay, so this is our grid, and I'm just going to plot these points out. Okay, so we have the y-intercept 0, -5, say it's somewhere here, and the x-intercept of 5 and 0, say it's somewhere here. Okay, this is 5 and 0, this is 0 and -5. Okay, let's just draw a grid let's draw the line in a different color. And this is what we expect. We expect, whoops, let's just make this line a little less deeper. This is what we'd expect. Okay, so you're gonna obviously use a ruler to draw this, right? However, we know that there's a hole at 4 and -1. So the hole would exist right here. So I'm just gonna make we can just touched area here, so just get rid of that. Okay, so there's a hole at 4, -1, so there's a point that's here that shouldn't exist. Okay, so that's basically how we're going to attach it, right? So you're obviously going to have a better sketch than mine is, but this is basically your line here. You should actually see a hole at that point, right? So that point doesn't actually exist. Okay, so keep this in mind, that's the hole. And this is basically your function. So this is basically an end. The end behavior of this is going to be the end behavior of a line segment. So as we look at the end behavior, as x approaches -infinity, as we go this way, right, y will also go down this way. So y will actually approach -infinity. This is an odd degree function. So thereby, you should have opposite end behaviors, right? As y approaches positive infinity, as you go this way for y, as x approaches positive infinity, as you go this way for x, y will approach positive infinity up here, right? So y approaches positive infinity. So that's the idea behind this. It's relatively straightforward in terms of a rational function and sketching it if you can see the presence of the whole. So make sure if there is a quadratic trinomial, that you factor first and then analyze.